Melissa, I love you. So big. My doom. That's not actually a really bad poem. They're four of the most virulent viruses that we've seen to date, and they're all over 10 years old. 1999, Melissa infected 20% of computers worldwide. Just think of that, it's a huge number of computers. In 2000, the ILOVEYOU virus, who remembers the ILOVEYOU virus? Yeah, I remember being up for like 3 days trying to sort out all of the files in our office that had been infected. It attacked tens of millions of people. The So Big virus was in 2003, and in 2004 we saw My Doom. If you think of monetary value back in 2004, it was $38 billion worth of damage from a virus. Viruses are horrible. Writing viruses, that's fun. But that's why you're here, right? So before we get started, I'm going to be one of those people and wonder why my clicker's not working. And use my keyboard to ask you all to please stand. So I need you all to take a pledge because we're writing a virus today. So I'd like you to raise your hand and say, I, insert your name. I, Ben, pledge to use the following information for good. If I fail to uphold this pledge, I promise to commit to 200 hours of community service, offering IT support via Twitter. This is legally binding. It's a verbal contract. Please be seated. Thank you. So what is a virus? A virus is basically three main components. You've got the infection mechanism. How does the virus actually get in? You've got the payload. What is the virus, or what does the virus do? And you've got the trigger. When does the virus actually do what it's supposed to do once it's in? Sometimes it's immediate, sometimes there's a delayed trigger. But essentially, if we break those down, we've got the spread and infect, so it'll get into your system. It'll look at file systems. Is there an attached Samba device? We all know how Samba is really secure recently, don't we? Spread to other files within the network. Maybe even look for local web apps, HTTP, do some end mapping to work out what servers are out there, what it now has access to now it's inside your local network. It'll find weaknesses. A chain is only as strong as the strongest link, right? So if there's a slight weakness, maybe you can find those. It'll do analysis of systems that you've got. Perhaps once it's found a web application that runs only internally, maybe it's based on an older version of Wordpress that still has a CVE that hasn't been fixed, and there's a way in through that as well. It might also have an updated zero-day list attack that it can get somehow in order to find the most recent vulnerabilities, even if the virus hit your system months ago. And then it just sits there and waits until it's triggered. Can you see? It'll just sit there and hide, and you won't know it's there, and it's just staring at you. It'll go, pounce. But obviously there's a whole industry dedicated to detecting these viruses. So how are these viruses detected? So the spreading of infection, you can detect file changes, but you change files every day. So how do you know when a file is changed because it's meant to be changed, and how do you know when the file is changed because it's maliciously changed? So perhaps you're looking at how many files are changed at once. If 10,000 files are suddenly changed within a matter of 5 minutes, there might be something wrong. If it's only 3, then it's probably okay. It'll do analysis detection. So again, that could be looking at file changes. It could be looking at network load. It looks at the systems in general, finds a baseline, and then looks for anomalies to system resource usage and those types of things. And they steal resources. Not generally your supper, but if you get infected badly enough, then maybe you won't be eating supper for a while. So these are the kind of things that viruses will do. And in order to catch those instances, or in order for a virus to evade the detection mechanisms, they will bear in mind things like they're looking for patterns. So I still remember back in 2001, the Trade Tower, 9/11, the head of security of the Israeli airport was looking at what the US were doing in terms of security, Patriot Act, all the rest of that. The way the Israeli airport security works is I believe maybe that's changed in the last 5 years or so, but at least 5 years ago they were still only using metal detector type scanners. They weren't using the backscatter X-ray machines. You've got to stand up and got a big swooshy thing go around you. They analyze people. Most of their work is watching people walking around the airport and thinking, are they doing something that's out of the ordinary? And they're used to picking up these subtle little details. So evading that is hard when you're analyzing at that level. If all you have, and I'm not going to make any comments about airport security in the US, but if all you have is technology that secures you, and you're not actually analyzing the way that systems are moving around that technology, or in the airport sense, the people are moving around the backscatter machines outside of that detection area, you probably need to do a little bit more. So viruses will try not to stand out, because even though when you look at it, it's obviously a virus, well, not obviously, but if you analyzed one file, you might be able to tell that it's infected. But how do you tell that something is intending to infect something? That's where you try not to stand out. Viruses also morph. So each time a virus infects, maybe it'll change the way it looks. So you can't do a big scan saying, well, I know this virus looks like this, so find me all the other files that have this signature in them. It might change every time. Obfuscate, hide in plain sight, don't actually look like a virus, look like a totally different thing. Perhaps if you're infecting a file, make sure that file is, for all intents and purposes, still able to do its job. And I'll show an example of that in a demo. And then possibly use cryptography of some sort. Scramble yourself so that even if by looking and analyzing the code you could tell there's something wrong with it, you don't actually know what it does, which makes it harder for analysis systems to determine specifically that something is a virus. It might just know that it's something that perhaps shouldn't be there, but we're not quite sure what it is. Finally, act benign. If you're a cat photo, everyone's going to want to watch you, or a cat video, even better nowadays. So if you purport to be something that you're not, but something that people want, people will install it. How many people have installed Google or iOS, Android or iOS apps on their phone, despite the fact they want all the permissions in the world? Yeah, exactly. I've done it as well. Lay dormant once you're in the system, don't do anything, just relax, analyze quietly, get some insight into the system that you're in. What can you do? Perhaps report it back to an external system so they can collect analysis about things, and then attack later. And take it slowly. If you operate slowly, if you only operate on those 3 files at a time over a longer period rather than 10,000 in one go, then perhaps the virus scanners won't find you. But you came here for a demo, right? So with that general concept of how viruses might circumvent systems, get into systems and then attack them, let's actually write a virus. So the first thing I'm going to do in what is quite possibly a very ironic turn of events, I came down with a virus a few days ago, so please excuse me for my slightly weaker voice. I hope you can hear me with the amplification. And my incessant coughing. And my inability to think while I'm talking to you. So I wrote, I was actually going to do this demo with a WordPress application from like 7 years ago that had a CVE that allowed you to upload files and in all sorts of really weird and wonderful ways. But in order to keep the demo simpler, I thought I'll just write an application that on the outside of it looks quite secure. And I'll take you through the code quickly just so that we can see the things that have been taken into account. And essentially, it's a simple gallery system. So let's have a quick look at the source code. That's not the one I wanted. Hello. Have I tried turning it off and on again? Can you go away? Oh, that's interesting. How about I quit that completely? And then unplug the monitor and plug it back in again. I think OpenOffice was hijacking something. So let's try this again. Hooray! Right. So, I'm just going to turn the podium so I can actually see what I'm typing. It's a tip I was given a few months ago. It means I've got my back to you, but we're all friends, right? You don't mind? So we've got a www directory in here, and in here I've got the main files that we need to be looking at are the index.php, the showImage.php, and the upload.php. Payload HTML files are for my ease of showing you the demo, but the PHP files are the one we're interested in. So let's have a look at the PHP files. So index.php, the crux of it is this bit here. So even though the clicker isn't working, the laser pointer might. Excellent. So we have here a for each, which basically goes through all the gallery images, all files, even if they're not JPEGs or PNGs or whatever, but we'll assume that all the files in the gallery directory are known, and even so, we're then making sure through this showImage.php that we're only showing images, and we'll come to that file in a second. But the most important part there is the dot dot, so I'm actually storing the images outside of the document root. So you shouldn't be able to load an image directly through a URL. It always has to go through this showImage.php. So there's a first level of security. And for those watching on YouTube later, I'm doing big air quotes at the moment, because this is totally secure, right? Then let's have a look at showImage. So if the referrer is in the current HTTP host, so if the image has been requested from this website, then continue. So we don't want to show the image unless it's the actual gallery application I've written that's requesting the image. Yep. So if it's okay, then let's get the same file name. So we make sure that the file name only has A to Z, 0 to 9, a dot, a dash, and an underscore in any capitalization. And then we prefix the dot dot slash gallery images to that. So now we should have a path that has no injection in the file name and points to a file, and it can only be a file because you can't put a slash into the file name. It'll load that file from the gallery images directory. Yep. Stop me if you've got any questions about where we're going with this. Then what we're going to do is determine the file type. So we'll take the file, it's the same file name, pass it into EXIF image type, and then convert that image type to a MIME type. And then we'll make sure that we output that MIME type. So the image needs to have a MIME type in order for it to be sent to the browser, and or the file will have a MIME type that's sent to the browser. So if there's a text file, for example, in there, then it's not going to return it as a JPEG file type. It'll return it as text. So the browser will always receive the correct header at the top for this image. And then we include the same file. So we're basically taking the contents of the file, and the showImage.php file is going to return that to the server, to the browser. Okay? So you make a request to this, you pass in the file that you want to load, it creates a sane file name out of it, makes sure the header that is sent back is correct, and then just dumps the data to the browser. Fairly secure? And then we've got the upload. So we have acceptable MIME types. I will only accept PNG, JPEG, JPEG, or GIF. If there's something submitted, because obviously if you hit the submit button or you hit this page without actually providing a file, it's not going to upload anything. We get the file name. Again, we make sure that the file type is in the list of acceptable MIME types by getting the file type out and then checking that it's in the array. Create a sane file name using exactly the same regular expression as we had in the show image. Yes, I could probably put it into a function, but as a demo, right? And then we move the uploaded file from the temp file that was created through the upload into the gallery images. And then we redirect back to the home page. So there's not a lot of room to inject a virus in here. Would you agree? Or does anybody disagree? Sorry? the include in the show image was totally unnecessary. Do you think that the file type header would alleviate that?
No, because you can still execute PHP code.
Bingo. So you can still execute PHP code. And I'll show that to you in a second. So for those of you who didn't hear it, this line down here, include same file name, will actually execute PHP code. So let's have a look at some demos. So I'm going to, first of all, show you the process of writing the virus, which is in here. And for my sanity, because as you can tell, I can't type and talk at the same time, I have something that will do the typing for me. Is this working yet? It is. So we're going to go through and we're going to get every single PHP file in the directory that this virus is going to run in. Next thing we'll do is go through each one of those files, and we'll open the file in read mode. Then we're going to open another file, which is the same file name with .infected at the end of it, and that's going to be in write mode. So we can't actually write to the PHP file that's currently executing. So what we're going to do is we're going to take each file, create an infected version of that file, and then move the infected version in place of the file that we're trying to infect. Does that make sense? So we go through, we add a comment for now, just for demonstration purposes. Files infected. We put that into the infected file. So infected here is the infected file that we're creating. So the first line is now going to say file infected. And then we go through the whole of the actual script that we opened up here. The open file is script. So for each line in that script, we then write that to the infected file. We then close the script file handle, and we close the infected file handle, and we'll just rename them around so that now we have just the file, the original file, which is infected. And we'll do that for every PHP file in the directory. Yep. So if we have a look at boom, there's the file we just created. Let's just have a quick look at example. So I've got an example file here, which is very complicated. I'm just going to run that. And we have the numbers 1 through 9. Thank you very much for coming. Now I'm going to run the boom script, which does nothing. Let's just have a look at example. It still does what it's supposed to do. But you'll see that the file's actually been affected. So it does exactly what it did previously. It's kind of benign at the moment. But for all intents and purposes, through executing it, we didn't notice any difference in operation, but we have an infected file. It's not very exciting, though. So let's go on to step 2. So same file we had before, but this time we're going to write the virus in there. So I've added virus in here instead of the comment infection here, or whatever it is I wrote. And then up the top here, I'm going to convert this into a function, and we're going to provide the virus to the execute function, which will then be inserted into the infection as the infected file. So let's just come down to the bottom and close that function off. Now, what is the virus payload going to be? We want the virus to be the actual file itself. So we're going to get the contents of the current file and load that in as the virus. Now, for boom.php, that's fine, but example.php had the echo 1 through 9 in there as well. So if we take the whole of that file and put that into another file, then we're going to change the operation because we're adding the echo 1 through 9 in as well. So we want to make sure that for every time this runs in the future on any infected file, we're only doing the actual virus. So we're going to add in here a comment to the top saying virus start. We'll come down to the bottom, we'll put a comment saying virus end. And then when we get the contents, we'll use substring to make sure that we're only using the code between those two markers. Does that make sense? Cool, so let's run that one. So we've got boom.php there. Example, again, is uninfected at the moment. So I just ran boom.php. Now I'll have a look at the example file again. And you can see we've got the virus in there. So if I let's create a new file, foo.php. Again, a very complicated application. But now if we run example, again, it looks like it's doing exactly what it was supposed to do. And if we look at foo, foo is now also infected. But the thing is, like, you can look at that and some code analysis tools would say, so it's loading all the files and then it's writing something into them and then it's renaming them. That's probably a little bit virus-like. So how can we get around the situation of code analysis tools for the purposes of antivirus detection, looking at code and saying, that looks like a virus? Because there are patterns out there that they can use. Let's do some encryption. So encryption and hashing, as you probably all know, is slightly different. Encryption is reversible. Hashing is not. We're going to be using encryption because the virus needs to be able to be decrypted in order to run. One of the things you'll see in the example is that we actually publish as part of the process the key for decrypting, because we don't actually care who can decrypt this. We're encrypting for the purposes of getting around detection systems, not for the purposes of secrecy. But let's have a look at it. So we'll edit this file again, and we're going to come down here and put in the encrypted virus. So I'm passing virus into encrypted virus, which is a new function, method, procedure that I'm about to create. So encrypted virus will basically generate a key. So in a longer version of this talk, I would go through how mcrypt works, but essentially you have an initialization vector and a key in order to create encryption, the parameters required to use mcrypt for the purposes of encryption. So we're going to generate a key, just very dirtily, a random string, which gets packed. We're going to create an initialization vector, which requires a size. We're going to be using CVC mode encryption. We create the initialization vector. This is used to start the way that encryption works. So very basically, the way encrypt works is it'll chunk your data into blocks, and you have an initialization vector which is used to encrypt the first block of data, and then that block is used as the initialization vector for the next. So it's almost like a starting point reference for how to then reverse the process afterwards for decryption. So we create the initialization vector. We then create the encrypted virus. So we're taking the virus here, we're passing it into mcrypt with the key and the initialization vector, and the result will be an encrypted virus. Now, the thing is that these values here, while the IV and the encrypted virus, are now all binary data. And we're going to be writing these into files which, for the best extent, are probably mostly ASCII type files, and putting binary data in them is potentially going to be a bit tricky, and could also be a red flag to antivirus systems. If there's binary inside a PHP file, sure, you might have put an image in line, but you probably haven't. And if you're putting images in line as binary data in your PHP files, you're probably doing something wrong. So we're going to encode them. Very simply, just base64 encode them, and then we'll add them into the payload. So this payload is actually a string that I'm generating at the moment. And that string represents the encrypted virus as a string containing our encrypted virus, which is now base64 encoded, the encoded IV, and the encoded key. Then, again, as a string, we're saying the virus is going to be decrypted using these values here, and we're base64 decoding them in line. And finally, we evaluate it. So we now have a string that's going to have these values here, the encoded virus, encoded IV, and encoded key, hard-coded into them, assigned to these variables, and then this variable will be the decrypted version of the virus. So when we eval virus here, we're actually evaluating the string, which is this whole virus.
Why do you need all the encryption if you don't care about encryption? Why can't you just base64 encode it?
You could base64 encode it, but antivirus systems base64 decode as part of some of their detection systems. So the fact that you could see the base64 is one way. Base64 is always the same. There's no seed. In hashing, you've got a seed, which means it's really hard to reverse. By creating the random key up here, the output is always going to be slightly different for every iteration of this virus, which makes it hard for pattern matching or reversing. So unless the antivirus system can actually detect that this is executed in a sandboxed environment and work out that the result is a virus, which is probably slightly tricky. Yeah, so that's the reason. So we evaluate the virus, which then gives us the value of virus again, and then we execute it. So it's almost the same code, only we've kind of wrapped it inside a function that generates the same code again. And then we return the payload, which is used in the function up the top there. Now, let's have a look at that one. So just to double check, we've got the new virus here, which has the return payload and all the rest of it. Our example file is currently uninfected. We run it, shows 1 through 9. Let's run boom. So boom does nothing, apparently. So let's have a look here. So there's our encrypted virus. And if I turn off line wrapping, you can see we've got the virus, which is a really long base64 encoded binary version of the encrypted virus. We've got the initialization vector and the key. We then call decrypt with those values, evaluate it, and then we execute. We call the execute method with that virus. So it's actually running the virus and then calling the execute function with that data. Does that make sense? So if I now look at our other example of then perpetuating that, so foo echoes foo. If we run example and we have a look at foo, it's been infected, which we expected. If we look at example, it's been infected twice. So we ran boom, which infected sample, example, and then we ran example, which infected all the files in the system in that directory, including example. And in fact, if we look at boom, so we've got the infection up here encrypted twice, and then the actual virus in plain text underneath. So boom is now a doubly infected already virus. It's not ideal. So, final step, before we go back to our gallery application, step 4, is to stop the virus from reinfecting itself. And we're going to do this very simply. Also, because I'm about to run this demo in a vagrant environment to actually delete way more than, or potentially affect way more than just the files in the current directory. I'm creating a get editable files, which will basically find all PHP files in the vagrant directory. This is also to stop me running it on my actual laptop and accidentally deleting all my files, which I have actually done. I couldn't control C fast enough. Luckily, it started in my own cloud directory for some reason, even though alphabetically it's not up at the top, but I was able to recover most of that, but that's a whole different story. So, we want to check that the file's not infected already. So let's go in, and we're going to grab the first line out of the script. So this is the PHP file that it's found that is about to infect. So the first line of the script, we're then going to create a hash of the file name plus some seed, and call that our virus hash. This means the hash is going to be different for every single file. It's also going to be unique for that file all the time. And that's important because if we just generated some kind of random marker, then statistically it's possible that that marker might already exist in a file somewhere in the world. So we want to try and create something that's unique to that file, but probably not used elsewhere. So a seeded hash of the file name seems like a good way to do that. So if the first line of the file that we're trying to infect is not the virus hash, then we're going to do the infection. So I'm just going to indent all of that and close that off at the bottom. So the first line has now been read. We've got a virus hash and we've checked. And now we're writing the virus into that first line. So for the purposes of making sure that it's not infected next time, we're going to add the checksum in at the top there. So now the next time this file is loaded, the first line here will actually contain the virus hash because we've just written it in. And then because we've read the first line already at the top, this while down here is going to skip that first line. So I'm just going to add that in again. add the checksum to the file, add the first line to the file. So now the infected file has the checksum, the virus, first line of the file which we've already read, and then the while loop will go through the rest of the file that we're infecting and write that to the new infected file. So I'm just going to skip through this stuff quickly, but basically get editable files is going to go through the directory, starting directory that was given, find directories and recurse through those, find files and return those if they match the pattern that was given at the top. Unfortunately, I don't have a quick button for skipping all of this stuff, but it's mostly boring. Right. So here's our new file. We've got the virus hash seed file name in there. We've got example, which is not infected. It's not. Autocomplete, when you're using Vim, doesn't autocomplete JPEG files, probably because you're not expected to edit them in Vim. Just FYI. So who here knows about the format of a JPEG file? Can you tell me what the first line indicates? Roughly. Exactly. That's basically the signature that tells the system that it's a JPEG file. It contains all the information that then persuades the system that this is a JPEG file. Let's write that. And now, let's break my computer again. Why are you not liking me? There we go. So let's come over here and we'll go into going viral, demo, files, images. There's my bread.jpg. You can tell this is the one I'm editing because there's my Vim swap file. It looks like bread. That is actually the one that I just made those changes to. So if instead of putting this in here, I go into step 5, boom, and I copy those 132 lines, and I paste them in here, and I then save that. There's the file. It's modified to 1619. It still looks like red. So, let's upload this. So there's the bread file. Update to 1619. Looks like bread. Upload. And we got a picture of bread. I can tell you're all excited. So let's go back into the www directory and look at the files by modification time. And you'll notice the bottom 3 files were updated at 19 minutes past 4. That's what I'm looking for. So let's just disable wrapping again. And we can see here that the index file is being encrypted, and you can probably infer that the other 2 files have been encrypted as well. Now, one thing I did with the, you'll notice that I loaded the file from step 5, not from step 4, is in step 5, boom.php, I've added another little bit of code down here. This bit. So basically, we're going to get the value of eval from the command line, from the query string. And if it's set, first of all, I'm going to echo it out, just so we can see that it's been received. And then we're going to eval. That's a nice little payload. So, an example of what we can do now is in here. So, let's find PHP info. So, if you can see down at the bottom there, localhost 8080 is the vagrant application I'm running, I'm just passing it to eval equals PHP info. Open brackets, close brackets, semicolon. That's it. There's PHP info coming out of the index file because of the virus and the eval. Something else we could do is send somebody an email. So this one's going to take a bit of time because it's connecting to my local mail server to try and send a mail, and then realizing that I don't have a local mail server, so it can't actually send the mail because it's a development box.
But you can only infect files which are writable by the web server.
You can only infect files that are only writable by the web server.
Yes.
But how many people have all files writable in their document root? Most people.
Your index PHP won't be, hopefully.
Can I get an honest sign of hands of how many people have a writable index PHP? I'd say we've probably got about 30%. It happens a lot. Sometimes it happens because it has to, because the update mechanism to keep the software up to date requires that to happen. Wordpress is one example of systems that often have a lot of files writable. I've picked on WordPress quite a bit. I don't actually have any issues with WordPress. I use it myself. But because of the way that its modular plugin system works, it does tend to have more vulnerabilities through the third-party plugins, more so than the core code. So you can see up there that it's tried to send me a mail. Now imagine if you had a sleuth of servers out there that were all hitting your server to send spam. They could use this mechanism for that. And the final one that I'd like to show you is this one here. I'll give you a second to read through that, work out if... So what this one's doing is it's going to create a file called a.php, and it's going to write into it the string header location is the phpconference.nl, and then file put that without append of any sort into the index.php. So if I click on this, it's now added that into A. Now, because the index.php is running, it can't modify itself. Same reason as we created the temporary files for the infection. So we've created a.php, but now that that's done, I can run a.php, which doesn't do very much. But now if I go to the home directory, other than the fact that my laptop is not currently connected to the internet, you can see that it's redirected to the PHP conference website. So you can actually change the entire operation of somebody's application if you wanted. Let's see if I can get the presentation back up. So I don't know what it's done, but it's moved the logo all the way down to the bottom there now. This is great. I love it. So there's a slide selector here somewhere, isn't there? But why am I telling you this? So one of the things that I wanted to do, I like to, my passions, as you might be able to tell, is security, privacy as well. And I like to think from the perspective of somebody who's trying to attack the system, as opposed to just always thinking about how can I secure this. If you think about how can I attack this, it gives you a different perspective on how to secure your applications. So think like a virus writer, hack around, play with it, see what vulnerabilities you can find. There are tools out there as well, which are great for doing code inspection, working out where there might be issues. But getting your headspace into that place can be a really useful way of discovering ways that you might not have thought before of how your system might be vulnerable. And I also did it to learn something new. And I highly recommend, and I don't actually make the slides or the demo live. Most of my other talks I do. But this code I don't make available because I don't want somebody out there to just download it and then like some script kiddie to repopulate it out there and use it or modify it in some way. If you want to write a virus, write it yourself because you'll learn so much from doing it. You'll have fun doing it. Depending on your work policy practices, you could actually call it training and do it on the job. That'd be fun. So I do want to remind you about your pledge. I will be monitoring all of your Twitter accounts to find out who's doing the 200 hours of community service. And before I finish, my opening, not poem, the worst poem in the world is actually from the Vogons. O freddled gruntlebuggy, thy micturations are to me as plurdled gabble blotshits on a lurgid bee. Group, I implore thee, my foonting turtledromes, and hooptiously drangle me with crinkly bindle wordles, or I will rend thee into the goober warts with my burgle cruncheon. See if I don't. I hope you all agree that my opening poem was a lot better than that. Thank you for your time. I hope you've learned something. I think we have time for questions.
What if eval is disabled?
What if?
Eval?
Oh, what if eval is disabled? Well, in that case, it wouldn't execute. In fact, it might even throw an error at some point. The thing with writing viruses, or the thing with what virus writers think about, is they don't care if your eval is disabled because somebody else's won't be. So disabling eval can be a good protection, for sure. Work around it by writing a file and including that? Yep.
Work around the info. You just find other ways.
But just with the include is more than enough. To
Yeah, the include there was horrible. Yeah. But it was intended to be. And the whole idea of that demo was, or the sample gallery app, was to show that even though you put all these other protection mechanisms into place, you only need that one, that weak link that enables the virus to come through. So you might think you're putting all these protection systems into place. It often happens you optimize for performance while you're still prototyping, or you optimize for security before you finished working out exactly how you're going to implement a feature. So think bigger and think how people might attack you. Take away the complexity, because complex code is hard to maintain. All of those things. Those are the lessons you can get out of like what you should be doing, not really how to write viruses. When you're writing viruses, just write dirty and have fun. Thank you very much.